Good morning, students. Today, I want to revise sequence and series. To learn sequence and series, first you learn some basics. Basically, the definition of sequence is a function whose domain is the set of natural numbers and whose range is a subset of real numbers. Take for example, when you consider f of n as 1 by n. This is a function, and now we take the natural numbers in the domain. Then natural number starts from 1, 2, 3, so on. So n for 1, 1 by 1 is 1, and n for 2, 1 by 2, n for 3, 1 by 3, n for 4, 1 by 4. So, so on. This is called a sequence, but whose range is a part of real numbers. Whose range is part of real numbers. This is called a real sequence. So, convergent sequence. A sequence an is said to be convergent if limit an as n tends to infinite is finite. Take for example, 1, 1 by 2, 1 by 3, so on, 1 by n, so on is a sequence whose nth term is 1 by n, and limit 1 by n as n tends to infinite 0. So here nth term tends to infinity 0, so that it is converges. A sequence an is said to be divergent if limit an as n tends to infinite is infinite or minus infinite. If nth term of the sequence as n tends to infinite, infinite or minus infinite, then we say that it is divergent. Take for example, here 1, 2, 3, so on and so on is a sequence whose nth term is n. Here nth term as n tends to infinite, it goes to plus infinite. So it is divergent. Now define infinite series. To define infinite series is, first you consider un is a sequence of real numbers. Then the expression u1 plus u2 plus u3 plus so on plus un plus so on is called an infinite series, and it is denoted by sigma un. So to discuss the convergence of infinite series, first you consider the nth partial sum. That is, you take the n terms sum of an infinite series. So Sn is equal to un plus u2 plus so on plus un. This is called nth partial sum. Now, the sequence of nth partial sum Sn converges to L, and it is written as sigma un is equal to L. Then L is called the sum of the series. Divergent series. If the sequence of nth partial sum diverges, then the series diverges. If nth partial sum converges, then the infinite series converges. If nth partial sum diverges, then infinite series diverges. And nth partial sum not tend to a unique limit as n tends to infinite. Then the series sigma un is said to be oscillatory. That means it is either convergent, it means it is neither convergent nor divergent. Take for example, minus 1 whole power n minus 1 whole power n plus 1. When you run from 1, n is 1, then what happened? 1. N is 2, that is minus 1. N is 3, that is 4. N is 4, that is, sorry, 1. And minus 1. So on. That is, for odd terms, it goes to 1. For even terms, it goes to minus 1. So limit is not unique. At that time, we say that it is oscillatory. Example, 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus so on. So to discuss the convergence of this infinite series, first you consider the nth partial sum. That is u1 plus u2 plus so on plus un. That is 1 plus 1 by 2 plus 1 by 2 square plus so on plus 1 by 2 power n minus 1. This is nth partial sum. Now, this is a geometric series whose sum is a into 1 minus r power n by 1 minus r. Here a is 1, r is 1 by 2. 1 into 1 minus r power n, 1 by 2 whole power n by 1 minus r, 1 minus half. So, denominator is half and take the reciprocal, then we get 2 minus 1 by 2 power 2 power n minus 1. Limit Sn as n tends to infinite, which is 2. So, we get a finite number. So that we say that the given series is convergent. Now, consider another series 1 plus 2 plus 3 plus so on. Now, consider the nth partial sum 1 plus 2 plus so on plus n. Now, find the sum of nth partial sum. That is, sum of n natural numbers is n into n plus 1 by 2. Now, limit Sn as n tends to infinite is infinite. When you get infinite or minus infinite, then we say that it is divergent. When nth partial sum is plus infinite or minus infinite, then we say that the given series is divergent. Okay. Now, series of positive terms, that is un plus u2 plus so on plus un plus so on, is called infinite series. If each and every u n is positive, then it is called positive term series. Now, auxiliary series. And every time to decide nth partial sum, it is difficult or complicate. So that we have to use some tests to decide the convergence of the convergence of inference series. So basically we use these tests so that, remember, those tests. One is auxiliary series or P series. It is in the form of 1 by n power p. Whenever you observe 1 by n power p form, then you take the p. If p is greater than 1, then the given series converges. If p is less than 1, then the given series diverges. Less than 1 or equal to 1. Most important, first you remember that auxiliary series or P series. It is in the form of sigma 1 by n power p. If p greater than 1, then it is convergence. If p less than or equal to 1, then it is divergence. Geometric series, which are in the form of r power n. If the r value lies between -1 and +1, then the series converges. If r value greater than 1 or equal to 1, then it is diverges. Oscillates if r is less than or equal to -1. Remember carefully. Now, by, by using P series or auxiliary series, we decide sigma 1 by n square converges, because here it is in the form of 1 by n power p and p is equal to 2, which is greater than 1. So sigma 1 by n square converges. It is 1 by n. That means diverges, because whose p value is 1. If p 1 or less than 1, then it is diverges by P series. Sigma 1 by n power of is also diverges, because whose P value is off and which is less than 1. 1 by n power 3 by t, that is converges, because whose P value 3 by 2 which is greater than 1. And one more thing is sigma mm, n power 4. What about this? That is, you write in the form of 1 by n power p. What about this? Here p is minus 4. Is it less than 1 or greater than 1? Yes, it is certainly less than 1. So that it is diverges. Whenever we have a test, that means you have to write in 1 by n power p. If it is in 1 by n power p, then only we decide converge or diverge. If p value is greater than 1, then it is converges. If p value is less than 1 or equal to 1, then it is diverges. Sigma 1 by n power p converges if p greater than 1 and diverges if p less than or equal to 1. Right. And also remember these formulas. That is, limit sine theta by theta as theta tends to 0 is 1, where theta is measured in radians, we know that. Limit tan theta by theta as theta tends to 0 is 1. Limit 1 plus 1 by n whole power n as n tends to infinite is e. And These are familiar. 1 by n tends to 0 as n tends to infinite. 1 by n square tends to 0 as n tends to infinite, and so on. Limit 1 by 2 power n as n tends to infinite 0, because it is in the form of r power n. Whenever we observe r power n, if the r value is greater than 1, then it is infinite. If r value is less than 1, then it is tends to 0. Here 1 by 2 power n, it means that 1 by 2 whole power n. So r is equal to 1 by 2, which is less than 1. It tends to 0. But limit 2 power n as n tends to infinite is infinite, because r is 2 and which is greater than 1. Then we say that it is infinite. Limit 2 by 3 whole power n as n tends to infinite. According to the geometric series, you have to find, whenever we want to find limit r power n, first you check r is less than 1 or greater than 1. When it is less than 1, it is tends to 0. When it is greater than 1, it is tends to infinite. Remember that. Here limit 3 by 2 whole power n. That means here r is 3 by 2, which is greater than 1. So that we write its limit as infinite. And also remember that n factorial is n into n minus 1, n minus 2, so on 1. So n factorial by n minus 1 factorial is n into n minus 1 factorial by n minus 1 factorial. So cancelling this, then we get only n. And also required this formula, that is binomial expansion 1 plus x whole power n, 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 and n minus 2 by 3 factorial x cube plus so on. So we require these formulas. Okay. Now you go for test. Okay. First you go for comparison test. In that we remember this, that is, if sigma un and sigma vn are positive term series, such that limit un by vn as n tends to infinite is finite, it means it is not equal to 0. Limit un by vn as n tends to infinite is L, which is not equal to 0. Then sigma un and sigma vn behave alike. This is limit form. That means when you have an infinite series, it is not possible to decide directly converge or divergence. Then we depend on Vn. First, you consider Vn. That Vn should be either geometric series or auxiliary series. So, after choosing Vn, you find un by Vn as entangent. If you get L, that is, which is not equal to 0. If the limit un by Vn as n tends to infinite is 0, then this test not worked out. You have to choose Vn in such way that limit un by Vn as n tends to infinite not equal to 0. Vn should be, it is in geometric form, or auxiliary form. Okay, right. Test for the convergence of 1 by 4 into 7 into 10 plus 4 by 7 into 10 into 13 plus 9 by 10 into 13 into 16 plus 1. First, you observe that in this series contains any variable or not. Yes, we observed that this series no variables. Okay, and then find out nth term of this series. If you have a nth term in this series, that's no problem. Otherwise, you have to find nth term. That is by using arithmetic progression or geometric progression. It's depending on the nature of the series. Here, first you find nth term in the numerator and then denominator. Here 1, 4, 9, so on. That is, we observed that it is in the form of n square. So 1 square, 2 square, 3 square. So numerator is n square. Okay. Now we go for denominators. First you take first term of 4 and second term 7 and this is 10. So 4, 7, 10. Find out nth term of 4, 7, 10. So difference 7 minus 4 is 3, 10 minus 7 is 3. If the difference is same, then it is in the form of arithmetic progression. For arithmetic progression, nth term is a plus n minus 1 into d. Here we don't know n, d for what? 3. So finally we have 4 plus 3n minus 3. 4 minus 3 is 1 plus 3n. Okay. 3n plus 1. That is first term. And again take 7, 10, 13, so on. Its nth term is 3n plus 4. Again take 10, 13, 16, so on. And 10, 13, 16, so on, its nth term is 3n plus 1. First, you have to find nth term and then check it. Put n for 1. Is it matched or not? Of course, sometimes you may neglect first or second terms to get nth term, but after that, you have to get all terms from this nth term. Okay. Yes. After checking, we have a nth term is correct. This is step 1, right? After that, you have to take higher power of n. That is, numerator is n square, no problem. And denominator take n common and pick out higher power of n. That is, here n taken 3 plus 1 by n. Here n taken 3 plus 4 by n. Here n taken 3 plus 7 by n. And n cube. For these three terms, we have three n's. So n into n into n, n cube. And then cancel it. 1 by n. Finally, highest n in the term is 1 by n. Okay. So you choose 1 by n as Vn. Vn should be either in R power n or auxiliary form. That is 1 by np form. Okay. or you simply take highest power in the numerator and highest power in the denominator. Here n square, denominator highest power is n into n square into n cube. N square by n cube, we have 1 by n directly. So we can choose any one of the ways. But for simplification to this, we get easy way, right? And now limit un by vn. This is un, that is, I mean, this is, sorry, this is un and vn is 1 by n. So cancel it n, then supply. Already we told that 1 by n as n tends to infinite is 0. That is 3 plus 0, 3 plus 0, 3 plus 0. So finally 1 by 27, which is not a 0. So if it is 0, our test is not worked out. If it is non-zero, then you go for yes, it is non-zero. Then go for Vn. That is Vn. Vn is 1 by n. Already we told that sigma 1 by n is divergent because auxiliary series, as per auxiliary series, if P is 1 or less than 1, it is divergent. So that Vn is divergent. Un by Vn non-zero and Vn is divergent. According to the comparison test, the given series is also divergent. If Vn is divergent, Un also divergent. If Vn is convergent, Un also convergent. Okay. Now go for second problem. Test for the convergence sigma 1 by root n into n plus 1. So basically this is a positive term series. That is, when you take n for 1, n for 2, n for 3, each and every term have a positive terms. So this is a series of positive terms. Now it is sigma un form. That is, nth term is 1 by root n into n plus 1. Here directly we have nth term. That's no problem. If it is in the series form, you have to write nth term. If it is given, that is very happy. After taking un, you have to simplify it. Take n common in this, n into n square. Square root of n square is n. Now you take 1 by n as vn. For taking vn as a trick of comparison test. Okay, alone terms, we have 1 by n is a higher power. So take note. Now find out limit un by vn. 1 by root 1 plus 1 by n. As n tends to infinite, 1 plus 0, 1 by root 1 plus 0 is 1, which is not equal to 0. Then you go for Vn. Vn is 1 by n. Here 1 by n power 1. It is divergent by P series. Therefore, by comparison test, sigma un is divergent. If sigma Vn is divergent, sigma un is divergent. If sigma Vn is convergent, sigma un also convergent. 1 by root n plus 1 plus root n. Simply take n common. That is 1 plus 1 by n. And finally root n taken out for both the terms. Root 1 plus 1 plus, I mean, root 1 plus 1 by n plus 1. Here alone term is 1 by root n. Okay, Vn is equal to 1 by root n. Find out un by Vn as n tends to infinite. We have 1 by 2, which is not equal to 0. Then you go for Vn, 1 by root n. That is n power half. Here P is half, which is less than 1. According to the P series, it is divergent. Okay. When sigma Vn is divergent, by comparison test, sigma un is also divergent. This is also same, but it is not possible to take n, so that you have to rationalize. To rationalizing, simply take the different sign and multiply with both numerator and denominator. Okay. So L1 term is 1 by root n cube. Take Vn as 1 by root n cube. Un by Vn as n tends to infinite. Finally, we have not equal to 0. And what is Vn here? 1 by root n cube. That is root n cube. It is n cube whole power of n power 3 by 2. Is convergent because p is equal to 3 by 2, which is greater than 1. By comparison test, sigma un is also convergent. 2 by 1 power p plus 3 by 2 power p plus 4 by 3 power p plus so on. Here un is 2, 3, 4. According to the arithmetic progression, we have nth term is n plus 1. 1 power p, 2 power p, 3 power p, so on. That is n power p. This is nth term of a series. N plus 1 by n power p. Now take n common in the numerator. N is, n into 1 plus 1 by n power p. Then a power m by a power n, which is 1 by a power m by a power n. So 1 by a power n minus, whatever you take, no problem. 1 plus 1 by n power p minus 1. Okay. Now 1 by n power p minus 1 as Vn. Un by Vn as n tends to infinite, both term cancelled, then we have only 1 plus 1 by n. Limit 1 plus 1 by n as n tends to infinity. 1 plus 1 by n tends to infinity is 0, which is not equal to 0. Now go for Vn. Vn is 1 by n power p minus 1. Okay, it is in the form of a p series, but we don't know the p. Sigma 1 by n power p minus 1 is convergent if p minus 1 greater than 1. That is, p is greater than 2. Divergent whose p minus 1 value is less than or equal to 1, of course. P is less than 2. Okay. And also divergent, which is equal to 1. That is, p is equal to 2. So finally, the series converges p greater than 2 and diverges p less than 2. I mean, p less than 2 or 2, no problem. We discussed in two cases. Sigma sine 1 by n. Okay. We take Vn as 1 by n. Un by Vn as n tends to infinite is 1, which is not equal to 0. Limit n tends to infinite, sine of 1 by n is 1. So that is, when you consider 1 by n as theta, sine theta by theta as theta tends to 0, which is 1. Sigma Vn, sigma what you took 1 by n. Sigma 1 by n is divergent by p series. By comparison test, sigma un is also divergent. Cube root n cube plus 1 minus n. Okay, here we use a binomial theorem. N cube plus 1 whole power 1 by 3 minus. That is n cube taken out in this bracket 1 plus 1 by n cube whole power 1 by 3 got cancel n into 1 plus 1 by n cube whole power 1 by 3 minus n. Okay. Now n taken out for both the terms 1 plus 1 by n cube whole power 1 by 3 minus 1. Okay. Now we have a binomial formula, that is here we using this formula 1 plus, here x is 1 by n cube, n is 1 by 3. 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on minus 1. This one and this one got cancelled. Finally, we have this. Now, supply n or 1 by n cube taken out. 1 by n cube taken out. Then we have 1 by 3 minus 1 by 9 n cube plus so on. So 1 by n cube into n both cancel, then we have 1 by n square. What I told, when you can take 1 by n cube common, n by n cube is 1 by n square. Then 1 by n square is alone, higher powers, so that Vn as 1 by n square. Un by Vn as n tends to infinite, which is 1 by 3 minus 1 by 9, so on. That means uh, after 1 by 3 term, all are 0, because as n tends to infinite, 1 by n, 1 by n square, 1 by n cube, so on tends to 0. So these are tends to zeros. Finally, we have only 1 by 3, which is not equal to 0. Then you take 1 by n square as Vn. So basically, sigma 1 by n square converges according to the P series. So sigma Vn is converges. By comparison test, sigma Un is also converges. Okay. 1 plus 2 power n, 1 plus 3 power n. Here also simply take t power 2 power n in the numerator and 3 power n in the denominator. Okay. Then root 2 by 3 whole power n as Vn. It is in the form of r power n. That is geometric series. Okay, no problem. Whether it is auxiliary form or it in geometry form. Un by Vn as n tends to infinite, finally we have 1. Because 1 by 2 power n is 0. R is equal to 1 by 2, which is less than 1. According to the geometric series, limit r power n as n tends to infinite, 0 if r less than 1, infinite if r greater than 1. You remember that. Okay, which is not equal to 0. Then sigma Vn is root 2 by 3 whole power n. Simply 2 by 3 whole power n by 2. No problem. Here R is what? 2 by 3. 2 by 3 is less than 1 according to the geometry series, which is convergent. So we conclude that sigma Vn is converges. Sigma Vn converges. So by comparison test, sigma Un is also convergent. Okay. In the next class, we will discuss about D'Alembert's ratio test. Thank you.